So how do we solve this? It says, what is the inverse of A equals 1, 4, 2, 3? So this is a 2 by 2 matrix. So what that means is that we have 2 rows and 2 columns. So the first thing that you want to do before you find the inverse is ask yourself, does the inverse even exist? So there are 2 rules for an inverse to exist. First, the number of rows must be equals to the number of columns. So since there are 2 rows and 2 columns, we can confirm that that is indeed true. And secondly, the determinant must not be 0. So for 2 by 2 matrix, the determinant is just the first diagonal multiplied together, and then you minus, then you do for the second diagonal, right? 4 times 2, and you subtract the second diagonal multiplied together. So 1 times 3 is just going to be 3, and 4 times 2 is just going to be 8. So 3 minus 8 is negative 5. And so our determinant is not 0, and so we can confirm that there is an inverse to this 2 by 2 matrix. All right, so now let's find the actual inverse. So to find the inverse of the matrix, we first have to understand how to find the inverse of a matrix. So to find the inverse of a matrix, we first have to understand that for any matrix, if we think of it as A, B, C, D, the inverse is considered to be 1 over the determinant, in other words, 1 over AD minus BC, right, what we just did on the previous page, times, and here we're just going to swap the first diagonal, so DA, we're going to change the signs of this, but this diagonal stays in place, right? They don't swap, they just change signs, so keep that in mind. So if you write this out, this is exactly how the inverse of any 2 by 2 matrix should look. So when you see the minus signs right here, it doesn't mean that it's going to be a minus, it means it's just going to change signs, okay? So if it was negative, it's going to become positive. If it was positive, it's going to become negative, and vice versa. So now let's find what the inverse is. So we had our matrix as 1, 4, 2, 3. So to find the inverse, we first would need 1 over the determinant. So the determinant was negative 5, so we can write that out. And then we would swap the first diagonal, so 3 and 1, we swap places, and change the signs of the other diagonal. So 2 is positive, so it's going to become negative. 4 is positive, same thing. And now what we have to do is we want to multiply this 1 over the determinant by every single term in this matrix, and then we've solved it. So it's going to be 1 over negative 5, 1 over negative 5 times 3, that's going to be negative 3 over 5. That's because opposite signs means we're going to become negative. If we have the same signs, like here, negative 1 over negative 5 times negative 2, it's going to become positive, right? Negative times negative becomes positive. And then we do the same thing, right? Negative times negative, negative 4, negative 5, those cancel out, that becomes positive. Again, then we have positive and a negative. We have a negative 1 over 5 times 1. It's just going to become negative 1 over 5. So just like that, we've gotten the inverse of this matrix, and that's all. For more help with anything math related, welcome to SavvyCle. Have a nice day.